Okay, so today we're going to discuss a little bit more power rules for our exponents. And what happens is we can always back it up into the product rule if we want to, but it becomes longer. So here we have, let's just take for example an m cubed. And let's say I have 4 of those guys. And you have to understand that the exponent only applies to that thing directly in front of it. So if we wanted to, we could expand this and say that yes, we have 4 of those parentheses. Better get 4 of them out there. And within those parentheses, we all have the m cubed, or that base cubed. Well, now I fall right back in the product rule where yes, I have an m. Whatever that is. Let's get rid of that. And then I just count out how many of them. 3, 6, 9, and 12. Well, this becomes a lot easier had I just gone m to the third times 4, which will still get me that m12 number, and it does it in a lot less steps. Here again, let's go ahead. Let's make this a little bit longer. So let's put multiple bases in my in my parentheses. Let's go parentheses. Let's go A, B, and C. Let's make A2 and B4 as far as exponentials. And then let's take this and cube it. Well, why would I want to take 3 of those parentheses and write them all out with them all containing the a squared b to the 4th c, when really all I need to do is I've got a squared, and then I take it times the 3 and get 6. So I'm taking times this 3 on the outside. I've got b to the 4. Well, I have 3 of those b to the 4, which means 3 groups of 4 gets me 12. And c, and yes, that does have an exponent. If you remember, we used to talk about that. If it doesn't have an exponent, it has an exponent of 1. So 1 times 3 is 3. And we make that, instead of multiple steps to get to that answer, we can simplify that right now. Now, let's go ahead to the scarier part of things, because we hate fractions, right? Fractions work the same way. Let's take a and b. Let's make a squared b to the 5th and cube it. Well, it's the same exact thing. This 3 applies only to that thing directly in front of it, which means, yes, I have 3 parentheses. I have a squared in the numerator of all of them, and I have b to the 5th in the denominator of all of them. And if you remember how we multiply fractions, it's tops times tops, bottoms times bottoms. And in this case, we have a's and b's, so nothing really reduces. So I get a to the 6th, b to the 15th, which if I would have gone back to the original and not freaked out about it, a squared cubed is 6. B to the 5th cubed is 15, and I can get to this answer so much faster. Now, our numbers, however, do play a part in some things. Let's say I have a 7r. I'm going to take that, group it, and cube it. Yes, 7 is a base, has an exponent of 1. 7 to the 1st times 3 is 7 to the 3rd. But that's not what we want. We want 7 times 7, which is 49. 49 times 7, which is 343. So here it becomes a little bit more problematic, and with our numbers we kind of have to slow down and think, is there an actual simplified number to that guy? And here again, the letters actually work easier, guys. R to the 1st or the 3rd is still R to the 1 times 3, which is 3. Let's take, for example, we have a fraction that is strictly numeric. And let's cube that thing. Now, yes, we can have 3 groups of parentheses that all say 1/2 in it. But when I take 1 times 1 times 1, I will always get 1 in my numerator because tops times tops. Bottoms times bottoms, I actually have 2 of those guys cubed, which means I have a 2 times 2 times 2. And 2 cubed is 8. And this works for all fractions. Now, as we get a little bit longer, and I'm going to do a couple more problems, we have our order of operations that we must take into place. So watch out for those. Let's say we have an x squared. Let's cube that guy. Then let's take that times x cubed, and let's take it to the 5th. Now our order of operations mean parentheses go first. Well, in either set of parentheses, you really can't simplify anything. The x squared can't be simplified, nor can the x cubed. So we go to exponents next. Well, yes, I can take the 3, and I have 3 of those x cubes, which means of those x squareds, which means I have x to the 6th. I'm going to leave those in parentheses for just a second. I'll kick back and explain to that why I did that here in a second. So I go to the next set of parentheses, which also has an exponent sitting here of 5. So x to the 3rd raised to the 5th is actually x to the 15th. Now I kept my parentheses to show you that I'm in multiplication. So we did parentheses, there was nothing to do. Exponents, we simplified our exponents. And now we're in multiplication. We have the same base. So our exponential, or our product rule, says that 6 plus 15 better be 21. So if we break this down by order of operations, or our order of operations never fail us, and we get our answer. So let's do one more of those. Let's throw in a number in this one, because, as I said, those can get a little bit goofy. So we have 3 x to the 4th y squared z. I'm going to go ahead and I'm going to cube that quantity. I'll make another quantity of y z to the 4th, let's say, and let's make it to the 5th. Well, we've got the same problem really as what we did earlier. However, when we have 3 raised to the 1st and now we're cubing it, we have 3 cubed. Well, 3 times 3 is 9, times 3 is 27. And we have to make that happen like that. That is a simplified answer. And now our letters all work very, very easily, just as we've practiced before. 4 times 3 is 12. Y to the 2 times 3 is 6. Z to the 1 times 3 is 3. Here again, I'm going to group that guy because we have another exponent to do in our order of operations. So we have y to the 1st times 5 is 5. Z to the 4 times 5 is 20. And now we're back to our product rule. We're 27, and really we could have put a 1 in front of this guy. So use that as you need to. 27 times 1 is 27. We have an x. We only have 12 of those because there's nothing in that second quantity. We have a y, and we have a 6 and a 5, which add our exponents, and we get 11 because we're multiplying by the same base. And we get z to the 3 plus 20 is 23. And here again, it gets a little bit longer, but our order of operations do keep us in the correct method.